All right, perfect problem 5, math 111. We're given this function and algebraically asked to figure out all these things and then sketch a graph. So first of all, end behavior. So what that is saying is we don't care what kind of happens in the middle here. We just want to know when the x gets really far negative or really far positive, what happens. So in this case, all we got to do is look at the leading coefficient. Maybe I'll write this down here. Because the degree is odd, the arrows are going to go in different directions. If it goes up here, it's going to go down here. If it goes down here, it's going to go up here. Maybe the other thing we have to look at is the leading coefficient, because the leading coefficient is negative. That's this -1 right here. The positive arrow, positive x arrow, goes down. In other words, what I'm trying to say is it's going to look like this. On this side, it's going to go down, and on this side, it's going to go up. So this picture can illustrate it, or as x goes to infinity, f of x goes to -infinity. When we go way out towards infinity on the x-axis, it's going to -infinity. The height's getting really low. And as, oops, there should be an infinity here. As x goes to -infinity, so that's this way, f of x goes to positive infinity. All right, I think that's plenty on end behavior. The next thing, y-intercepts. That's the easy one. Y-intercept happens when x equals 0. So all we got to do is figure out what is f of 0. In this case, it's 0 plus 0 plus 0, or -0 plus 0 plus 0 minus 0, I guess. F of 0 equals 0. So y-intercept is at y equals 0. Good enough. Roots of f of x are just the x-intercepts, which happen when the height equals 0, height equals 0. So we want f of x to equal 0 and solve for x. Well, f of x is negative x to the 7th plus x to the 6th plus x to the 5th minus x to the 4th. So what we got to do is solve this equation. Well, we have x's in all of these. In fact, we have x to the 4th in all of these. I kind of like the leading coefficient to be positive, so maybe I'll factor out a negative x to the 4th. And what that leaves me with is x cubed minus x squared minus x plus 1. Something like this. And then what I want to do, maybe I'll switch colors here, is factor out the inside here. On the inside, I got 4 terms. I can factor by grouping. So if you look at these first 2 terms, they have an x squared in common. And what that leaves me with is x squared minus 1. Nope, it's not true. It leaves me with x minus 1. And to be left with x minus 1 over here, I would have to subtract a 1. And so what that leaves me with on the inside here, when I factor out x minus 1 from both terms, is this. And then don't forget, you still got the negative x to the 4th out here, and this whole thing equals 0. And then we can go one step further. This one's done. But this is a difference of squares. So it factors into x plus 1, x minus 1. And if we rewrite these, we got negative x to the fourth, x minus 1 squared, x plus 1 equals 0. So what we get are roots at 0 from this guy, 1 from this guy, and negative 1. I'm going to write those a little better. So roots happen at x equals 0, 1, and negative 1. And the multiplicities, the 0 happens 4 times. The positive 1 happens twice. And the negative 1 happens once. And I think that's everything we had to do algebraically. Yeah. So now we're just going to try to sketch this graph. It doesn't have to be precise by any means. But let's see, we have a y-intercept at 0. So we should cross right here. End behavior. On this side the arrow goes down, on this side the arrow goes up. We got roots at x equals 0, which I got already dotted. X equals 1. Got a 1 right there. And x equals negative 1. And we know that we start out over here going up, and we're going to end up somehow here going down. That's better. And then we got even multiplicity at 0 and 1, but odd multiplicity at negative 1. So what odd multiplicity tells us is that it goes through this point, well, almost at that point. Try that again. It's going to go through this point and then somewhere down here turn around. However, it's different at this point. At 0, it's got even multiplicity, so it kind of hits that and bounces off and goes back down. And then at 1, it's also got even multiplicity. So it's going to hit this guy and bounce back down. So it's a very approximate graph we have here. We don't know how far down it goes down here or here. But that's not really important. All we care about for our purposes is the end behavior of these arrows, the y-intercept, our 3 x-intercepts, and the multiplicity. And so this graph captures all that. I'll label it as f of x, and that is the end of this perfect problem.